Hi and welcome. My name is Linus Rosenqvist and I'm finally got around to do a tutorial on these vellum worms things. Let's just see what we're gonna do. So this is what I have here. It's it's kind of a vellum sim of some worms playing in the mud. The rendering is a bit flickery, but yeah, you get the idea, and that's not the important thing. And the comp is a bit off, but yeah, it's actually my first time using Nuke. I've been using After Effects for I don't know, 15 years, and I just wanted to try to do this a bit more professionally, so I used Nuke instead. Yeah, I wasn't that easy to comp, but yeah. Yes, so basically what we have is we have a vellum sim, and we have a terrain, and we have a water sim, and that's basically it. We have some volumetrics and things like that as well, but yeah, that's not that's like just extra stuff. So let's get started. I talked way too long about this. So we're gonna start off. We're gonna do this in a couple of steps, since it would be way too long to do it just in one go. So the first thing we're gonna do is to create some kind of worm, and look at some animation for that. The vellum sim will be driven from some we give it a rest position, the worm, and we also give it an animation, and then we compare those two, and that is the force pretty much. And then we have a whole lot of trouble with getting the orientation and stuff like that correctly, but that's a later question. So in this first part, I thought we were just gonna do the worm and set up the basic animation. And the thing is with this is that you could and you should probably use like a better model, but for those that don't have a better model, and unfortunately there are no good models for free on TurboSquid, etc., what I could find, so therefore we do something procedural in Houdini, but that's definitely not necessary for this project. You could follow along from the second part of this probably if you have your own model, but yeah, I'll just do something, and it will be decent. By the way, I won't cover like the rendering etc. from this because it took a bit too long, and I mean it's just kind of a procedural setup with not that advanced. But I will go through the basics, but then you could like do your own stuff probably better. Yeah. So okay, let's get started. So first we're gonna do it on a GeoNode, of course, and we're gonna call this worm, and we're gonna tap inside. So the first thing we need is some kind of line that will be the like the base of the worm. We do it in the X direction, and we give it a fair number of points, maybe 14. And yeah, let's start like that. Then we're gonna call this start line, maybe. Oh, I had to have caps. Sorry, I don't like caps. Start line. And then we're gonna put on a wrangle because we need to give this some kind of UV. So we say set U and P scale, because what we're gonna do is just a basic copy to points. And by the way, yeah, this is many parts of this is basic, but some parts is a bit more advanced. So you could probably follow along, but like the matrices stuff might be a bit over your head if you're just new to Houdini. There are a lot of good tutorials on that. Some guy that did a little bit of math things recently that posted in Houdini Artist on Facebook. You can look at that if you want to get up to speed with those things. It's not that hard, but it might be a bit tricky to get your head around it when you first start. Okay, never mind. So we start with giving it a U attribute, and we just float the point number, so we get that as a non-integer, and we divide it with the float of the num-pt, and we subtract 1 from that. Of course, we should add here as well. This gives us a value between 0 to 1, running running over the points. So you see we have 0 to 1. 0.00, 0.13, which is the last, is 1. The reason you do -1 is because you start on 0 instead of 1. And then we do a p-scale thing. So we initialize that and we do that over a ramp, which we call p-scale. And we use the @u and we just multiply it with a multiplier kind of channel float let's call it like that. And we just set a p-scale multiplier of maybe 0.15, and we can wait with the ramp until we have a copy the points. So now we drop down a sphere. Let's just make it radius 0.7, give it a frequency of 6 maybe, and we do a copy the points. Copy the points. There we go, and we take the sphere and we drop it down here, and we can see we get a big stuff here. And that's because our ramp is kind of off at the moment. So first thing I'm going to do is I'm going to set the interpolation to B-spline. And then I'm going to drag this up so we get a little bit of start. And we do something like this, and we just make it smaller towards the end as well. Okay, so it's way too big. What the fuck's wrong? Something's wrong here. Oh, sorry. I had this primitive. It should be a polygon, of course, and that uniform phase could be 1, and the frequency should be 6, rather. Sorry for that. So we have a little bit of a divide here. I don't think it will matter in the end. I think we could continue with this because we're going to reshape it anyway. Maybe just bring it up a little bit here. Yeah, maybe. So yeah, we try. We'll see. So we just make this into a VDB, and this is not very efficient, of course, if you want to keep this low poly, which you probably would want to, a bit more than I'm doing. So do something point, we can start, we don't have to go that far, but we can maybe do like this, 0.2. Good. And then we're gonna see this, and we're gonna bring down a tube, because we wanna cap it in the bottom here. So we bring down a tube. I'm gonna do it like that. We can make it a polygon. We should do it on, let me see, the x-axis, right? And we're gonna add end caps, and the center could probably be 0.5. And let's bring down the radius to 0.2 maybe. And the height could be a little bit longer just to be sure. And we can do a lot of columns to make this round. Maybe, fuck it, make it 100. And just move down the center, I guess. Maybe something like that. That's probably good enough, maybe a little bit higher. So we may do a VDB combine here. And it's just because I'm lazy and doing this as VDBs. You could of course model this a lot better, but I can't model for shit, so that's not really a solution for me, especially not in Houdini. Oh, we have to make this into a VDB of course as well. The thing is also right now is I did this such a long time ago. Not that long time ago, but I made this a couple of weeks ago, and I really haven't looked at it since then, so I just rendered it during Christmas, and I'm kind of not exact. That's might go a little bit slower because I'm a little bit confused on what I'm doing, kind of. So that's good. We have our base here, our very nice looking worm or lava or whatever it is. So what we also want to do is we want to add some kind of feet to it. I had that on the other one, and I think it's a pretty nice feature. You can see when it upside down. You have 3 feet, which is very, very odd. But I'm going to do 2 here because I don't see any point in having 3. So let's just do 2 feet of it. So what we're going to do then is we're going to take our line again. We're going to maybe, yeah, I guess this is pretty neat. I should sort things out so it's a bit easier to understand and see what we're doing. So we're just going to bring this down, and what we're going to do is we're going to subdivide this line with a value of 1, which gives us the double amount of points, as you can see. And then we're gonna just take out every other point, so we get, because the thing we want here is we have this copied on every point, and what we want is the spaces in between first, because right now it's a bit flat down here, so we want to give it a little bit of insert down here first before we add the feet. So in order to do that, we subdivide the line and then put on our angle again. And we're just going to do a very simple thing. So we say if at pt_num modulus 2, which gives us every other point, so to speak, if that equals to 0, then we remove point. So let's do it like that. And what we can see now is we have, if we look at this, we have like the other thing, which is good because that's what we want. We're just gonna move this down a little bit, maybe something like 0.3 maybe, and then we're gonna take this VDB combined, we're gonna convert it back into polygons, which we get there. We don't want to see the points. And one thing we want to do here is we want to array this on. So we just put an array node, and we take points, we take minimum distance, we take that, and we take a collision geometry, and that gives us something that is where I want it to be. I think, yes, it seems like the points are in the intersections. It's a bit off somewhere, I guess. Maybe I have to move it down a little bit further. Yeah, that's better. Good. And we just gonna drop down a couple of points here. And what we want to do is put down some lines here. So this is the target geometry. And what we also want to do, maybe we should put it, trying to make this neat, but I'm not a very organized person, so it's chaos. We put on a line, and that line could be just maybe we do it make it a little bit, let's see here. Yeah, we should do it on the origin Z, I think is correct here. Sorry if I'm a bit slow on this one. And we just want the origin probably a bit, we can make it a little bit longer. I think I did that last time. I'm just going to copy this and make the origin minus that. We don't have the need to see, we can minus distance divided by 2. There we go. So we have it in the middle, which is good. And then we just do, we're gonna do a line U here as well, like a UV attribute thing. So we're just gonna call that give UV. Give U is actually the correct word here. So we're just gonna call it line U. I don't know if that's a good number. And we do the same thing as we did before. So we float the pt_num, and we divide that by float num pt. The thing is, I need to add more points as well here, -1. And we also need to give this a lot more points. So we're gonna give it, I don't know, 50 points. Good. And then we're gonna do the copy to points here. Let's see if this works. We do that, and yeah, here we go. We have these points inside that. But the thing is, we also want to ray this one, because now it's not in the same place. So we're just going to drop down. Just going to copy this ray node, drag it down here. Why don't... Okay, there we go. And delete that. And we just put it there, and then we do that. So then we ray it onto this as well, which is what we want. It's not... Maybe it's working. Yeah, it's working, I think. And then we're gonna give these some kind of scale thing. So we put down a wrangle. Oh, maybe we do it like this. We put down a polywire first, so we can see what's going on. Yeah, looks really good. So what we're gonna do is we're gonna do it at a P scale. And we're gonna give it a lot more divisions. We're gonna give it like that many divisions. It looks really good. Yeah. So this is of course very off at the moment. Just gonna put down a null here just to see what's going on. So maybe they are a bit off here. Yeah, I think it's just a matter of size here. So let's put down our wrangle. And we can add p-scale here instead. Y-radius instead of 0.1 we do at p-scale. Scale. It has a p-scale that's way off, of course. So let's just do the p-scale thing instead. So we do p-scale. Can I write? I can't talk and write. Like I said, if you watch any of my other videos, you see that I can't really talk and write at the same time. So we do a p-scale shramp. And we have a p-scale already, so let's use the... Oh, we don't have it. Sorry, just talking nonsense. I can't talk. P-scale. Okay, sorry. And we do... we use the line U that we just created, and then we just multiply it by a multiplier. Channel float multi. Let's do it to that. Hello, p-scale multiplier. Maybe we should be a bit more correct there. P-scale multiplier. So let's do it like that. What's wrong here? A point line use, sorry. That's good. And then we look at the polywire and we get nothing because we have 0 here. So then we need to give it a ramp. And the ramp should probably be something like small. We're gonna give this as a B-spline. I'm gonna give it a B-spline. I'm gonna do it really, really small, 0.0056. Here we go. Now we're starting to see something. And we're gonna give it big in the middle, and we're gonna get it down there. It doesn't have to be 0, but we do something like that maybe. So these are gonna intertwine with the other thing. And then we need to make this into a VDB. We can tweak this later on as well. We're just gonna take a reference from the other one up here. So we use the same scale. And then we're gonna reshape it a little bit, I think. Just make it grow a little bit. And I don't know how much, but let's try something like 4. Maybe that's too big. And now it's getting a bit clumsy here. It's gonna move things. So here is our, there's our like last thing. So here we can do a VDB combine again. Combine. And maybe we should move this whole thing to the side so we can maybe have a downstream thing that looks okay. Sorry. Gonna move this up, I guess. Do something like this, and then we can go down here. I never really understand how to organize a node tree nicely. And then we do STS difference, and we get some cut-ins here, which is good. And then we can smooth it. And you're free to do whatever you want here, because I'm just doing something really quick and dirty just to get something that is okay. So yeah, I think that's good for our little worm dude. Maybe I grew it a bit too much here. And maybe I should just reshape it again, because it looks a bit strange there. Just grow it again. I think that's nice because it gets a little bit like that, and maybe just do the take this down to maybe reshape here we can take down to 3, I guess. Something like that. We will add, I mean, these things will a bit, yeah, I think that's good enough. It's not a perfect looking worm, it will never be. That's why you should get your own model. When I did it last time, I did also do a volume VOP in order to give it a little bit of randomness. Just gonna, because I'm lazy, I'm just gonna rename it density, so I don't have to do a bind in the volume VOP. So I renamed the volume density to noise density instead. And then here you can do pretty much whatever you want. You can make a very ambitious thing here, or you can just do as I do and do something that's fast. I mean, here I'm not really. I mean, this won't be like a production ready thing. It will be more to be like this is a way of doing it. So we drop down a noise, 3D noise. We drop down a static maybe, unified static. And let's just, I just gonna give it a little bit of randomness. That's why I'm doing AA noise, so I can take the AA noise and add that to the position in order to get that a little bit of randomness to this noise. And we're just gonna add that to the density. And now it will be way too much and you won't see anything. So first and foremost, we're gonna bring down the final amplitude to something really low. Let's just do like this. Copy parameter. We want the same in all axes. So just paste relative reference, paste relative reference. Bring this down to 0.01 maybe. Nothing happens. So let's bring it up to 0.1. There we go. There starts to happen things. What we want to do is, what we need to do. We could probably, let's just give that as a reference as well to the tube. So we have the same resolution. And let's just bring this up. We don't need this high resolution. Bring it up 0.5 and give it a lot more voxel bands in order to be able to do something within the volume VOP. Because right now it just kills it when it moves outside. So here, let's see what happens if we add a little bit to this. It just shrinks it, which is a bit odd, I guess. Let's see what happens if we bring up the frequency a little bit. There we go. Here we get something. I don't know if this is interesting or good or whatever, but we should also, of course, play with this. We could add some kind of fractal, hybrid terrain. It's a bit soft. It's not as harsh as the FBM. It doesn't really look any difference because I think it's too low res to see it. We could play with the resolution a little bit, maybe bring it up a little bit. This is all up to you. The thing is, like, bring it down to 0.3 maybe. See how that looks. Yeah, I mean it gets a little bit more interesting when you add some kind of noise to it, but then again the model will be hard. Of course, for the simulation we will remove a lot of the details. We will do a poly reduce of it. So let's see if we bring this one up maybe or down. Bring this thing down. We bring this thing up maybe a little bit too. The thing is it looks a bit off here, but we will smooth it and move it, so it might be good to do something that's a bit more chaotic start thing. Let's try it like this. It doesn't really matter. You can, like I said, play and do it more ambitiously if you want to. We're still gonna do a reshape afterwards, so you will lose a lot of details. So let's bring this up to a lot, like 4 maybe. Yeah. So this is a bit organic shape, I guess. There's some randomness. You could, of course, also analyze the curvature and grow it rather here than in the steeps. So you can do a lot of things if you want to. And yeah, you could also add a face to it or whatever. But right now we're gonna try to add some kind of feet to it. And for that we could use our old line from up here. This one. I think no, maybe the start line. Yes, the start line would be good. So let's just do object merge down here. Let's rename this as well so it's known as, yeah, it's start line, sorry. So we do object merge. I think this is a easier way of doing it so you don't have to do all those. Let's see, start line. There we go. There we have the start line. And yeah, we need to move this down. So let's do that. Minus 0.1 maybe. And then we're gonna do the classic where we just ray it on. So we're gonna convert this into a polygon. What we're gonna, yeah, like I said, we're gonna do the feet thing. So we convert it and we ray it. And again we do points and we do minimum distance and we take that one and we take that one and we'll see what we get. Did anything happen? No, it didn't. Because we converted the volume, we should go to the polygons and then it will work. Yes, so there we go, we have our line that's being converted. The thing is we want this on two sides, so we're gonna do a transform and we're just gonna move it a little bit to the side and let's say we translate it 0.5 and we do another transform in which we copy this and we paste relative reference and we do it as a negative. And then if we merge these two, we get these. Maybe that's okay. Yeah, I think it's okay. Maybe a little bit less. 0.44 maybe? Yeah. And then we just ray it again. There's a lot of raying going on. So we do that and we use the same thing as we did before, that one. So it's on. And then we add a sphere here as well. And that sphere could be a bit longer than its high. So let's bring this down to 0.6. We copy that, paste relative reference, and we have this thing here. And we bring it down to something really small. Yeah, that's our feet. And let's just copy the points then. Could also, of course, do this smaller when they're further forward and bigger when they're further back. It looks awful, but yeah, yeah. Let's do it as a polygon mesh, maybe. Doesn't really matter. Yeah, let's do it like that. And yeah, we wanna maybe do a little bit of things with these as well. So we're gonna make them into a VDB polygons. Yeah, and we have to, maybe we should keep the, just gonna keep the same size as we had before. So there we go, we have our feet. Maybe they're a bit big though, so let's just bring it down to uniform scale 0.15 instead. Yeah, I think that's good. And we could take the same volume drop, but maybe do a little bit different with it. Just give it a little bit of randomness to it. And of course, would you model this, it will probably look a lot better, but this is how I'm doing it at the moment. So yeah, it's called surface here, so we need to change it to density. And we need to give it a bit of, maybe something like that. It's hardly seen, you can hardly see what's going on, but yeah, let's try. We see what's going on when we merge it. And this is only for that one, so we take this and then we do a VDB combine down here. And we do, SDF union. And here we have the small, okay, they're too small now. They're definitely too small. Let's bring it up to what we had. Put this on this side and bring it up to 0.25 instead. I think that's good. They're a bit obvious, but these does, yeah, maybe it's cool. They look a bit off, but who cares? Yeah, this is our worm. Yeah, yeah. Maybe reshape it a little bit and smooth it a little bit. So maybe we take down the reshape here to like 2, and then we're down here. Instead we do a reshape again. And yeah, maybe do a smooth, or maybe not. I think it's good enough. They seem to fit in quite good. Good. Then we can do a convert VDB and convert it to polygons. And this will be a high-res mesh. It's 100,000. You could of course do this higher or lower or whatever you want. So yeah, this is it for the first little part, and we will continue with the animation of it. Thank you.